Today, we'll learn how to use Arnold, the renderer that comes built into Maya. Since modeling alone doesn't show the final result, we'll apply materials and lighting with Arnold and render an image. First, open the Hypershade window and pin the left panel. Under the Create tab, select the Arnold shader category to see Arnold's dedicated shaders. Texture and utility nodes must be connected to a shader before they can be used. You can't use a texture or utility node directly on an object without a shader. The most commonly used shader in Arnold is AI Standard Surface. After creating an AI Standard Surface shader, you can press the 1, 2, 3, and 4 keys to switch between different display modes. Now, let's assign the AI Standard Surface shader we just created to the object. Now, click the A button in the viewport. This is the Arnold viewport render. It allows you to see the rendered result directly in the viewport. However, you won't see anything at first. That's because there are no lights in the scene yet. Let's add a simple light. Go to Arnold Lights Area Light. Move the light slightly, and the object will become visible. Arnold primarily uses exposure to control light intensity. Arnold calculates the final light intensity as intensity times 2 exposure. Each increase of 1 exposure value doubles the brightness. A smaller light creates tighter, sharper reflections, while a larger light produces softer lighting. Light shape changes the shape of the light source. Try different shapes to see the differences. The spread value controls how widely the light is distributed. Now let's use Arnold RenderView instead of the viewport render. Go to Arnold RenderView. You can also open it from the Arnold shelf. Click the IPR button to update the render in real time while editing lights or materials. The button next to it starts the final render. Once you're satisfied with the result, use this button to render the final image and save it. Click the arrow below to open the snapshot panel. This is useful for comparing renders before and after changes. You can switch between snapshots to compare different results. Now let's take a quick look at the top menu. The first button displays the RGB image, and the next one shows the alpha channel. In Arnold RenderView, clicking an object in the render also selects the actual object in the scene. Now let's import a simple object and build a basic scene. Next, let's take a look at the Arnold render settings. First, let's look at the Common tab. This section is mainly used for sequence rendering, such as animations. Image size lets you set the output resolution. I usually render in HD 1080 for testing and use 4K for the final output. For now, set the resolution to HD 1080. We'll cover the remaining options later when rendering image sequences. Next is the Arnold Renderer tab. This is where you control the rendering quality and noise settings. The most important settings in this tab are sampling and ray depth. Create a ground plane and assign a new AI standard surface material to it as well. First, create an area light and place it above the object. In the light's attributes, increase the exposure value to around 7 for testing. For demonstration purposes, let's lower all the sampling values first. Sampling controls the overall rendering quality. First, let's look at camera. Camera controls the anti-aliasing samples. It determines the number of primary rays traced per pixel and has the greatest impact on overall image quality. Typically, values between 3 and 4 are used, while 8 is common for high-quality renders. If you compare the camera value of 1 with 3, you can clearly see that the noise is reduced at 3. However, it also increases the rendering time. Next is diffuse. Diffuse controls the samples for indirect lighting, also known as global illumination. It calculates diffuse light bouncing from one surface to another. A value of 0 disables that indirect lighting contribution. Starting from 1, indirect lighting is calculated, and increasing the value reduces noise but also increases render time. If you compare a value of 0 with 1 or higher, you'll notice little change in the areas directly lit by the light. However, in the shadowed areas, you can see that indirect diffuse lighting is now being calculated. Arnold provides a variety of shader presets. These presets make it easy to apply different materials. Next is specular. Specular controls the samples for reflections. Increasing this value reduces noise in reflections. Next is transmission. Transmission controls the samples for refractive materials such as glass. Increasing this value reduces noise in refractions. Next is SSS, or subsurface scattering. SSS simulates light entering a surface, scattering beneath it, and exiting again. It is commonly used for materials like human skin or wax, where light scatters beneath the surface, rather than for metals or plastics. Increasing this value also reduces noise. Now let's look at ray depth. Ray depth determines how many times rays are allowed to bounce through the scene. Total specifies the maximum number of ray bounces. In general, total should be equal to or greater than the combined ray depths of diffuse, specular, transmission, and volume. Even if diffuse samples are enabled, indirect lighting will not be calculated if the diffuse ray depth is set to 0. Increasing the diffuse ray depth to around 3 allows light to bounce more times, producing brighter and more natural shadow areas. Next is specular ray depth. If the value is too low, reflections may be cut off in scenes with multiple reflective surfaces. For highly reflective scenes, it's recommended to use a higher value. Next is transmission ray depth. If multiple refractive objects overlap, a low value may prevent rays from passing through all of them correctly. In such cases, increasing the value is recommended. Finally, let's look at transparency depth. Transparency is used for transparent materials without refraction. For example, materials that use opacity maps, such as leaves or wire fences. Connect a grid texture to the opacity slot in the Geometry tab to control transparency based on the texture. Compare the results when the value is 0 and when it is greater than or equal to 0. Transparency depth is not affected by the total ray depth, so in most cases you can simply leave it at the default value of 10. Thank you for watching. If you found this helpful, please subscribe and hit the bell for more Maya tutorials. Thanks.